All right, so Unit 4, Day 3, Hyperbolas. I'm going to go quick because I already have this up, so if you're sitting at home, you may need to pause the video and copy this down and then listen to what I'm saying. They look like ellipses, except that there's a minus sign instead of a plus sign. And so that's a small difference in the equation, but a very big difference in terms of what the graph looks like. Hyperbola kind of sounds like parabola, so it kind of looks like a parabola, except that there's two of them. If the x thing comes first, it's left and right. If the y thing comes first, it's up and down. Again, it's always negative, that's as opposed to ellipses where it's always positive. For the A stuff and B stuff, the A is always first. Is locking up there. It doesn't matter which one, it matters which one's first, but if you'll just remember to go A, whatever's under X, go that many in X, and whatever's under Y, go that many in Y, just like with an ellipse. And we'll talk about how that looks and what that means for the graph. But the first couple steps is the same for an ellipse and for a hyperbola. Just whatever's under, we'll find the center the same way. If it's under X, go left and right. If it's under Y, go up and down. So there's a lot of similarities between ellipses and hyperbolas, even though their graphs look completely different. And then lastly, it's always equal to 1. So there's another similarity with an ellipse. So the shapes look completely different, even though their equations are pretty similar. All right, let's do an example. For the ellipses, remember we did one long example. Here we're going to break it up a little bit and do two examples. Y minus 2 squared over 4 minus x plus 1 squared over 9 equals 1. It's definitely a hyperbola because of the minus sign. The y thing comes first. So this is one of those things where I would do a little sketch of it even before I write anything else down. I know that when I get done with this problem, it better look something like that, because it's a hyperbola, the y comes first, so it's an up and down hyperbola. Occasionally students they'll get all the details right, and then they'll graph an ellipse because they just got lost kind of in the problem, and they found the vertices right, and they found the foci right, and then they just forgot they were working a hyperbola. So I think it's helpful to do a little sketch right away that whenever I get done with this problem, it better look something like that. That's kind of that parent function approach. All right, the center, find it the same way you do an ellipse, although be careful because for an ellipse, the x always came first. Here, we just need to be a little bit more careful. The x would be -1 and the y would be 2. So don't just read them off in order. Make sure the x and then y. Oh, and once again, for notes, you got to make a neat graph. For homework and test, the graph paper will be provided, so that'll make it a little easier. So my center's at -1, 2. All right. Well, even though we don't exactly know how to draw this shape, we do know that how many we should go up and down. How many should we go up and down? Thank you. A is 2. So we'll go up and down 2. Those will be my vertices. Those will be the bottom and the top of the branches. So let's see, that's -1, 4. And -1, 0. And then let's go left and right, 3. Now, those are not vertices because our graph is not going to go through those points, but they're important points to draw because they're going to help us draw the graph. If you list them as vertices, I probably won't even take off, because if you do everything else right, then it would be obvious that they're not vertices. So far everything is exactly like the ellipse, right? We find the center, up and down, whatever's under y, left and right, whatever's under x. Now, instead of making an ellipse, because it's not an ellipse, I want to draw a rectangle with those points. Draw the rectangle. We'll see why in a minute. Yeah, well, right now we'll see why. After we draw a rectangle, the diagonals, or the extended diagonals, meaning we're going to extend them out past the box, the extended diagonals make the asymptotes. So it's nice to have a straight edge. Your ID works well. So use the corners of the box to make the diagonals, but extend them out, because those are going to be our asymptotes. All right, to find the foci, c squared equals, well, when we change from ellipse to hyperbola, we change that middle sign. When we change from ellipse to hyperbola, we're going to change this sign to a plus. So a squared plus b squared. That's good. That's our more normal one. And it's nice here, if you get a and b backwards, it doesn't matter because you're adding them. So c is the square root of 13. And then when it comes to graphing, let's see, square root of 13 is in between 3 and 4. 3 squared is 9, 4 squared is 16. So the exact answer is square root of 13, but in terms of putting them on the graph, 3.5-ish is close enough. Like, I can't tell the difference between 3.3, 3.5, 3.7 on the graph. It's all, especially on a homemade graph like this one. It's still the distance from the center on the, be careful, it's not the major axis, it's on the main axis. Because this, actually we could have sketched this in already. Maybe it would have been a good idea to. So there's my vertice. It's a very wide hyperbola. Yeah, it's probably a good idea to sketch the hyperbola in before you do the foci. All of these graphs wrap around the foci. It's like, so the foci were in the center of the ellipse, or in the middle of the ellipse, because you wrapped around it. Here the foci are going to be right here and right here, because they're going to wrap around the focus. So we're going to go up and down 3.5 from the center. So 1, 2, 3 and a little bit. 1, 2, 3 and a little bit. And so it wraps around the foci. Again, that's kind of your hint that you're doing the focus correctly. All right, again, the center was -1, 2. For this particular problem, we went up and down to find the foci. So which coordinate do we need to tweak? The x one or the y one? The y. So I need to take this y coordinate and we'll tweak it the same way we did with an ellipse. We'll go plus and minus square root of 13. So there's my picture, there's my foci. The last thing we'll ask for, well, there's two things we'll ask for. There we go. Asymptotes. So head out the back. I'm going to pause this and we'll come back and get it later. Asymptotes. So there's two lines there. That means there's two equations. But there's a real easy way to do this asymptote thing. Much better than y equals mx plus b. And that is, if you remember this form of a line.
Good morning, Kingwood High School. Thank you for doing a great job on the fire.
All right, so this is called the point slope form of a line. And it's particularly helpful if you have a point and a slope. So y equals mx plus b is probably what you're used to, but this form is so much better for asymptotes. Because the point, in fact the point that's on both of those lines is the center. And the slope, right, rise over run, we can find from the picture it's a over b or b over a. Don't memorize that, just look at the picture and figure out which one it is. And one of them is positive, one of them is negative, so you can get both lines with like one statement. So y minus 2, hold off on the slope, and x plus 1, because that was the center. In fact, I can't get it all on the screen at one time, but there we go. Y minus 2 and x plus 1. It'll always match this initial equation. In fact, some people will write the asymptotes first because they can do it just from here without doing any pictures, because they know it's going to be y minus 2. They know it's going to be x plus 1. So the point is the center. The slope is always change in y over change in x, rise over run. And so you look either at the picture, we went up 2 over 3, or you could look at the equation. The change in y is 2, change in x is 3. So 2/3, but put a plus or minus on there to get both of them. So the asymptotes seem like the tricky thing to find, but they're really pretty easy because you know the center, you know change in y over change in x. This is also one of those places where if you read in a book about this, it gets confusing because they'll either say it's b over a or a over b, and that depends on who's under y and who's under x. Don't worry about a's and b's. Use what you know. Slope is change in y over change in x. So either look at the picture or look back here. Change in y is 2, change in x is 3. So the slope is up 2 over 3. And then one's positive, one's minus. They both go through the center. So finding asymptotes is really not that hard to write the equation of them.
After the and point slope form, are we converting it back to the standard form or keeping it?
Great question. Do I need to change it? No, leave it like that. Leave it like that. Yes, great question. In calculus, we leave a ton of things in this form because calculus is all about finding slopes. And so point slope form works great, and we like that form of a line. It doesn't have to be, you've been so well trained to do y equals mx plus b, or to solve for y, and that's fine, but you don't have to do that. In fact, we like it like this, because if you don't have anything else and that's all you have, it's still easy to graph a line because you can find the point, -1, 2, and you know the slope is plus or minus 2/3. So this is a perfectly acceptable form of a line. So yes, can you leave it like that? Yes, and please leave it like that, so that you don't mess up, distributing, moving things over. Like it's not hard, but you run the risk of making a mistake if you go further. Leave it like that. All right, last, and then we'll do one more example. Eccentricity is still C over A, so that's good news. It's the same as an ellipse, except for a hyperbola, the eccentricity is always greater than 1. You don't have to memorize that, but it might help you. So C we found earlier was square root of 13. And A is the first one, so A is 2. So there's the eccentricity. All right, let's do one more example, and I'll tell you about what the assignment is. It's the next thing in the worksheet packet, but it's not all of the next thing in the worksheet packet. You might could guess what we're about to do. Actually, this is one from the worksheet. So get your worksheet packet out, and this is number 3. On the hyperbolas worksheet. Although I said get your worksheet out, I think you should probably do this part on the notes, because this is one where there's not much room to work. All right, so we've done a couple of these. A little bit different with hyperbolas, but a lot of the process is the same. Let's group the x stuff. Let's group the y stuff. And move that 55 to the other side. What do you think we do next? We do want to complete the square, like big picture. That's what we want to do next. But before we can do that, we need to take out the 9. So x squared minus 6x. What do I need to take out of the second set, though? Don't take out the y, because that'd mess things up. We do take out the 4, but I also want to take out the negative. Because, we don't like dealing with negative y squared. We want a positive y squared. So take out the negative, and that'll mean this is plus 10y. Equals 55. B over 2 is negative 3. Half it, square it, add it. So half is negative 3. Square it, we get 9. Add it, we do plus 9. But what do I need to do to the other side? Yeah, multiply by that 9, so write plus 81. Again, maybe that feels weird to write plus 9 and plus 81, but you're adding 81 to both sides. B over 2 equals 5. Square it, we get 25. So I'll write plus 25. But what did I really do to the left-hand side here? I got to multiply it by negative 4 and do minus 100 on the other side. Ooh, 55 plus 81, that would be 136. Minus 100 is 36. Almost there. Very similar to the ellipse. What do we do next? Divide by 36. reduce. So x minus 3 squared over 4 minus y plus 5 squared over 9 equals 1. And now you're ready to answer the rest of the questions on worksheet 3. Although even before I start answering, I noticed that x is first. So I know it's going to be a left and right hyperbola. And again, kind of like parent functions, I'm going to do a quick sketch of that so that when I finish, my graph better look something like that. All right, the assignment is Unit 4, Worksheet 2, but only 1 through 8 for today. And actually 1 through 8, omit number 7. We'll do the rest of those tomorrow. So 1 through 8, except number 7. Number 7 is a parabola, and we haven't talked about those yet. So try those. I'll answer some tomorrow, and then we'll look at kind of the word problem stuff tomorrow as well.